guys, welcome back to a case of Econ Struggles. Today I'm going to talk about discounting in economics. I'm going to talk about both discrete time discounting and continuous time discounting. As always, timestamps are below if you would like to jump around, but let's go ahead and get right into it. So remember that discounting comes out of sort of just the utility maximization problem, where you can think about dynamic optimization, where you have some consumption in period T or CT, and you have some consumption tomorrow or in period T plus 1. And your time preferences are going to tell you that if you're thinking from today, well, the utility you get from eating, I don't know, coconuts today is not going to be equal to the utility you're getting from eating those coconuts tomorrow, because those coconuts tomorrow are happening 1 day from now. So you're going to discount it a little bit. It's not the same as having that coconut today. And so ultimately what we do is we use this beta to describe your time preferences, or the amount of patience you have, the amount you're willing to equate eating a coconut today with eating a coconut tomorrow. And we're just going to expand that out a little bit and now say that beta is just 1 over 1 plus delta, where beta is still our discount factor, which is the same as before. And now delta is this discount rate, or how much we're willing to be patient between today and tomorrow. So I've done a couple of other videos on that, and basically in all those videos what happens is we say, well, the reason this is working, just for a different example, is if I have $100 today, if I put that money in the bank, that's going to be worth more than $100 tomorrow or in the future. It's going to be $100 plus R, whatever R is, or in this case, 100 times 1 plus delta to the T. And if I have less than $100 today, then, well, that's maybe going to turn into $100 in the future. So again, just saying $100 in the future is worth less than $100 today. And $100 today is worth more than $100 in the future. And again, this is all because of this time discounting, or this discount factor. So again, in some of my other videos, I've been using beta, but we can also use beta as 1 over 1 plus R. That's fine, that's just a definition. And in some classes, instead of R, they use this delta. So 1 over 1 plus delta is going to be our discount factor, where delta is our discount rate. And so if I just use that with my future value equations, what you're going to see is that the present value is just going to be the future value divided by 1 plus R to the T, or if we're using delta, this is going to be the future value over 1 plus delta all to the T, like that. You can do the same thing with streams. So I've talked about net present value, again, finding the present value of streams, both finite and infinite. If you want, that video is going to pop up in the top right corner right about now. But all we're doing is we're replacing R's with deltas, and the formulas are still going to work exactly the same way. So for discrete discounting, if I have a stream that starts in period 1, it goes to period T, I'm just going to take out a 1 over 1 plus delta, so this can be 0 and T minus 1, and I'm going to get exactly that same formula that I've talked about in that other video. Okay, so that's discrete time. Now if I'm going to have continuous time, which is going to be important if you talk about things like the lumber industry or when to cut down trees, we're going to use PERT, which comes from finance, which just says that future value is principal times e to the RT. Okay, well then I can just resolve this the same way we did for the present value stuff with discrete time. Say that present value is future value over e to the RT. Again, I'm not using R, maybe I'm using little delta, and so that's just going to become future value times e to the negative delta t. So that's all we're doing. These are just two different formulas you can use for time discounting, or the present value of money, depending on whether you're assuming discrete time or continuous time. And so hopefully that'll help you as you're going through your class to figure out how exactly you need to take present value. So again, if this video or these videos in general helping you out, please like and subscribe. See you next time for another case of Econ Struggles.